Hello, my name is Andrew Bourne, Operations Supervisor at Allmix Concrete, and today I will be running through boiler operations. There will be three sections to this presentation: Section 1, Boiler Overview, Section 2, Boiler Operation, and Section 3, Testing Procedures. Before we begin, it should be noted that some of the contents of these videos is for informational purposes only. If, after this video, you are unsure of any boiler operations, please contact myself, a maintenance team member, your plant supervisor, or territory manager before making any changes. The fire tube boiler, which we use at all locations, consists of the body, which contains the water and the tubes, the furnace, which produces the heat, and the preheat tank, not seen in this diagram, which prevents cold water shock and optimizes the performance of the boiler. Some plants also have a blow-off vessel to control blow-offs. Taking a look inside the boiler, we see the furnace providing heat through the tubes, hence the name fire tube boiler. The heat travels in the tubes across the body of the boiler. In this diagram, the heat passes through 3 times, making this a 3-pass boiler. As the heat travels through the tubes, the heat is transferred to the water surrounding the tubes. The water is boiled into steam, which collects at the top of the boiler. The flue gas remaining is sent up the stack to safely exit the building. Today, we are at Allmix Brampton looking at this Hurst boiler. It is very similar to most boilers at our plants, and everything we go over here should be applicable to the rest of the boilers at Allmix. As mentioned before, here's the preheat or condensate tank, which is used to circulate and warm fresh water before sending it to the boiler. Here we see the chemical treatment container, which will be discussed later. And over here, we see the boiler registration and certificates. The most important items to see are the date of expiry on the certificate of inspection and the correct name and location on the certificate of registration. More information on the boiler can be seen on the boiler plate, typically located here. This gives some key specifications of the boiler. First, let's take a look at the intake water. The intake water at this location is located here. We can see the soft water system, which is used to remove hardness from the water, and the water gauge that measures the amount of water entering the system. The water enters the preheat tank or condensate tank, where it's mixed with steam from the boiler based on this calorimeter. The calorimeter measures the water temperature and activates a valve in the steam line to allow more steam into the tank. The boiler pump pumps the heated water into the boiler based on water level signals from the boiler control system. The furnace is where the natural gas is ignited and the resulting hot gases are sent through the boiler tubes. This also acts as the main control panel for the boiler. Here is where we will start and stop the furnace, and hence the boiler, where we can switch the boiler into low fire mode when steam is not actively in use. It's also where we can see the current boiler activity and demand, and where we can see the cause of alarms, allowing us to troubleshoot or understand which actions need to be taken to correct the system. Down below, we see the ignition panel. This controls the ignition flame of the furnace and can also provide alarm or error messages. Finally, the alarm silence button can be used to manually silence the alarm once an operator is present and actively working to solve the cause of the disturbance. So, as seen in the introduction, the furnace heat passes through the tubes of the boiler several times, and then it exits up the stack and out the building. One of the most important controls for the boiler is the water level. Too high, and water is sent through the steam lines, causing wet steam and leading to many other problems. Alternatively, if the water level gets too low, the tubes become exposed. Without the water absorbing all the heat in the tubes, the steel of the tubes become extremely hot and can lead to tube damage or failure. This sight glass is used to identify the water level inside the boiler. And these are level alarms. Inside them is a float that sends a signal if it moves past a certain level. This is conveyed to the central control system and will trip the corresponding alarm. These pressure controllers are used to set the maximum and minimum pressures desired in the boiler. These determine the value at which corresponding alarms are activated and also act as indicators for the automatic system to adjust accordingly. And on the other side of the boiler, we have another water level measuring device. The boiler steam exits the top of the boiler into a steam manifold. The main steam shutoff valve is located here. From the manifold, the steam travels through all steam lines, such as the return line to the preheat tank. Down below, we have the bottom blow-off valves. These consist of a fast relief valve and a slow release valve. In this setup in Brampton, the blow-off exits to a water tank beside the garage. These valves here can also be used to perform side blow-offs and to check the water column. Many boilers also have surface blow-offs, which are typically controlled automatically based on the amount of fresh water entering the boiler. Finally, some boilers are equipped with a blow-off tank. This controls and redirects any unforeseen or unplanned blow-offs. For example, if the boiler becomes overpressurized and the relief valve blows open.